All right, here we are looking at section 6.5. So our essential question, the big thing we're thinking about, is how can you solve an exponential equation graphically? So our learning targets for this section are to first solve exponential equations with the same base, then we're going to be solving exponential equations that have different bases or unlike bases, and then finally we're going to be solving exponential equations by graphing. So let's look at our first core concept. So we're dealing with the property of equality for exponential equations. So I'm really looking at the same base, right? So two powers with the same base are equal if their exponents are equal. So I can set this up. So I see that I have 2 to the x equals 2 to the 5th. So I know that since my base is the same, that I can set my exponents to be the same. So I can have x equals 5. So I know that that is true. I also know that if I have x equals 5, I can work backwards and I can make them both the exponent as long as my base is the same. So this is written in numbers and then some algebra, but that's really what that means is if my bases are the same, then I can set my exponents equal. So let's look at these couple of examples. So I see I have 3 to the x plus 1 equals 3 to the 5th. So the first thing I notice is that my bases are the same. So if my bases are the same, then I can set my exponents to be equal. So I would have x plus 1 equals 5. So then to solve for x, again, I just subtract 1. So I know that x equals 4. And I can just simplify, and that's all I'm asked to do for this part A. So let's look at B. I've got 6 equals 6 to the 2x minus 3. Well, this one doesn't have an exponent, so what do? Well, I know that if I don't see an exponent, my exponent is 1. So then I can set up my equation. 1 equals 2x minus 3. So first step I do to solve for x is I add 3 to both sides. So 4 equals 2x. Then since I'm multiplying, I undo that multiplying by dividing. And so I end up with 2 equals x. And I fully simplify that. So now I'm looking at example C. I see again I have the same base. My base is 10 here, so I set my exponents equal. So 3x equals 2x plus 3. So again, I want to get all my x's to one side and everything else to the other side, so I'm going to go ahead and subtract 2x from both sides. When I do that, I end up with x equals 3. So now I've gone through and I can simplify and solve for x even if my x is in the exponent. So here are a couple of practice problems, the monitoring progress, so go ahead and try these. So the second thing I have, and this is example 2 in your book, is I see that I don't have the same bases. So the first thing I have to do is I have to get to the same base. So I want to get it to probably the smallest base that I can. Well, and I know that 5 is as simple as it can be because I can't multiply anything times itself to get 5. So I want to try and get this 125 into a base of 5. So I've got 5 to the x, and I know that 125 can also be written as 5 to the 3rd, because I know 5 times 5 is 25, times 5 is 125. So now that I have both sides written in the same base, I can set my exponents equal. And so I end up with x equals 3. So now let's look at part B. Again, my bases are not equal, so first I have to get them to be the same thing. So I know that 4 can also be written as 2 squared, right? But I can't forget that I have that x out there equals to the x minus 3. So remember our properties of exponents is when I have an exponent taken to another exponent, I can multiply. So it becomes 2 to the 2x equals 2 to the x minus 3. So now that I have the same base, I can set my exponents equal and solve. So I'm going to subtract x from both sides, so I end up with x equals negative 3 for this part B. So let's look at C. So I see that I've got a base of 9 and a base of 27. Well, I know that both of these can be broken down a little bit more, so let's do that. I know that the square root of 9 is 3, so 9 can also be written as 3 squared. And then I have this other exponent to deal with that was still there. I know that 27 can also be written as 3 cubed, because 3 times 3 is 9, times another 3 is 27. So I've got 3 cubed to the x. And again, with my properties of exponents, I can go ahead and multiply. So when I'm multiplying this 2, I have to multiply the 2 times everything. So I've got my x plus 2 in parentheses, which ends up giving me 3 to the 2x plus 4 equals, and then 3, this becomes 3 to the 3x. So now that my bases are the same, again, I set my exponents equal, and I solve. So since I have x's over here already, I'm going to just subtract 2x from both sides. So I end up with 4 equals x. So just the biggest thing is to remember, try and get to the lowest base possible. Oftentimes, you'll see here in parts A and B that one of your two examples will already be in the base that you're going to use. But sometimes if we're looking at part C, we have to come up with the best base to use. So this is where it's going to take some time to think about, what do you know about things that are multiplied times themselves? We're going to generally try and get down to very simple numbers, like 2, 3, 5 is very simple, right? We don't usually want to use 4 because 4 can also be written as 2 squared. So the more simple and low numbers you can get to for your bases, the better off you'll be. So now we're going to be looking at if my base is not a whole number, right? If we're dealing with fractions, what do I do to start with? So here I want to go ahead and rewrite my fraction with a negative exponent, right? And I know that 1/2 to the x is equal to 2 to the negative x. Remember my properties of exponents is when I have a negative exponent, I flip the fraction. So same thing here is if I want to flip the fraction, I end up with a negative exponent. So now I again have to write 4 in base 2, and I know that 4 written in base 2 is going to be 2 squared. So I can set this up, so 2 to the negative x equals 2 squared. Now that my bases are the same, I set my exponents equal. I don't like negative x, so I multiply times a negative 1, and I multiply times a negative 1. So I end up with x equals negative 2. So now let's look at this part B. Again, I see that I have a fraction here. So I want to rewrite the 64, and I'm going to have to break down the 64 into a different base, and then I can solve that a little bit more. So let's start there. So I know that 64 can also be written as 4 to the third, because I know 4 times 4 is 16, and 16 times 4 is 64. And I can leave this in base 4 because my other side was given in base 4. I don't have to simplify any further, even though on the last slide we talked about generally we go to a base of 2. But since I was given a base of 4, I can stay there. So now I want to get rid of this fraction, and just like we did in part A, I know that when I flip my fraction, I have a negative exponent. So I end up with 4 to the x plus 1 equals 4. And now that I've flipped it into the numerator, I have to make my exponent negative. Now that my bases are the same, I can go ahead and set my exponents equal and solve for x. So since 1 is being added to x, I subtract 1. So x equals a negative 4 in this example. So here you have a couple more monitoring progress. So try these to see if you're on track and if you're going the right direction. So now we're going to be using a graphing calculator to solve these couple of examples. So if you have a graphing calculator, go ahead and use that. If not, you can always use Desmos, right? So here's Desmos, and I'm just sliding my screen over just a little bit so we can see what we're looking at. So you'll see that I have A, we're going to look at part A first, is going to be 1/2 to the x minus 1 equals 7, which you can see right in here. This is what we're going to look at first. So the first thing I do is I write a system that explains both of these. So I'm going to have y equals 1/2, right, to the x minus 1, and y equals 7. So now when I go to Desmos, I go ahead and I type those equations in. So y equals 1/2 to the, and when I'm using exponents, I want to make sure I have my parentheses so nothing gets lost, x minus 1. So there's my first equation, and my second one was y equals 7. So now I have those two equations graphed, and in your book it tells you to use the trace feature or the intersect feature. When we're using Desmos, we can literally just click on the point where they intersect, because that's given to us, and it tells me that they intersect at x equals -1.8. And we're going to round to 2 decimals generally, unless you're told otherwise. So it's going to be negative 1.81. And I round that up because this number is greater than 4. So I can see that when I have these two, my x is approximately a negative 1.81. And I solved this by graphing it. And I know I can graph it, and I would want to graph it rather than try and set my base as equal, is because 7, right? I don't know of any number that I can multiply by itself to get to 7. 7's not a pretty one, so I'm going to go ahead and just graph this. So now let's look at part B. I'm going to do the same thing. I'm going to write my system of equations. We're going to do green for B. So I have y equals 3 to the x plus 2, and I have y equals x plus 1. So now I can go back to my graphing calculator, or if you're like me, you can just use Desmos, and I write out both of my equations. So y equals 3 to the x plus 2, whoop, and it, again, see how if I don't use parentheses, it doesn't like me very much, and it gives me the wrong equation. So there's that. And then I can also graph y equals x plus 1. So now I can see in my graph that these are going in different directions, right? So here's my one equation, and here's my second one. So these lines, these graphs, these two equations never touch. So since they never touch, I have no solution. Okay? So there is no solution for this one, which sometimes that will happen. Okay. So here we go. Here's a couple more just monitoring progress, seeing if you can use that graphing calculator to solve the equation and find the point of intersection. So that's it for this section. Let's look back at our learning targets to see if we were able to meet them all. So our first one was solve exponential equations with the same base, right? That was something that looked like 2 to the x equals 2 to the third. And since my base is already equal, I can set my exponents equal. Then my second learning target, solve exponential equations with unlike bases. So that looked something like 2 to the x equals 4 to the third. Well, first I have to change this 4 to the third to have the same base. So I'd have 2 to the x equals 2 squared to the third. And then from there I can follow my properties of exponents and solve and set my bases equal. And then thirdly, solve exponential equations by graphing. So I used the graphing when I had really funky bases that I wasn't going to be able to get to simplify. And you'll see in your monitoring progress, you'll have sometimes bases that are decimals, right? This is not going to turn out pretty, so we know we're going to use graphing to solve these ones. And we can use either a graphing calculator or we can use Desmos, whichever one is more useful to you and that you have access to. So now you're going to go ahead and start working on the homework exercises for section 6.5.